Good day, viewers. Today we are still going to be deliberating on differentiation, like the derivative of an exponential function. One practical example is the one written on the board. If y is equal to x raised to the power 3 sine x, that we should find dy dx. Find dy dx. That means that we are going to differentiate this given question with respect to x. Okay, solution. Remember what I said in our last video, that if we have anything raised to power like question like this which is given here, is for us to introduce natural log to the left and the right hand side. So I will introduce my natural log to the both side, natural log of y and the natural log of this x 3 sine x. And if we still look at my last video, if we have a problem like this in log, that there is a law in log that says that the power will go behind, like this in log is equal to p log m. So I'm going to apply this law. Let me just write the law. I'm going to apply this to use and solve this now. So now this is my m. My m is this, then my p is 3 sine x. So this is equal to p become 3 sine x into log m. Then my log m is what? Is x. So here become log of this is equal to this. Now the next step is, after we have introduced our natural log to the both sides, is for us to differentiate. The first step is to apply the natural log. Then the second step is to differentiate the both sides with respect to x. So now I'm going to differentiate this with respect to x. Now the derivative of this with respect to x, and I will differentiate this. Remember what I will do? I will bring out my 3 outside so that I will differentiate. This is my log a, log base a, that is natural log. Please remember this place. So now I'm going to differentiate this. Now I will bring out my 3. Then this is what I will do: derivative of sine x and log x with respect to y. So in our last video, I still said something, that if you are going to differentiate this, that the derivative of this is 1 all over y dy dp, dy dx. If here was z, here will be 1 all over z dz dx. If here is L, it will be 1 all over L dl dx. So now the derivative of this becomes 1 all over y dy dx. We have been able to differentiate this now, my left hand side now. Now let's go to the right hand side. Remember that looking at this now, we have sine x and the natural log of x, which is this. We are going to use product rule to differentiate this, and our product rule is keep u, you differentiate v, and you keep v, and you differentiate u. That is it. So we are going to apply this to differentiate this now. My u now is, my u is sine x, and my v is the natural log of this. Now the derivative of sine x with respect to x become, my u prime now is equal to cos x, and now my v prime is equal to 1 all over x. The same thing that was here, 1 all over y. So now the derivative is 1 all over x. So I'm going to substitute this given data into this problem. I will divide my board. So this is 1 all over y. The y, the x is equal to 3. This is my 3. And my u is sine x. V prime, look at my v prime here. 1 all over x plus my v is the natural log of this. And my u prime is cos x. This is my cos x. So this is the same thing of writing 1 all over y. The y dx is equal to 3 into sine x all over x plus this cos x. And for us to make the y dx the subject formula is for us to multiply the left hand side with y. So this is 1 all over y. The y dx into y is equal to 3 sine x all over x plus log x, natural log of that, cos x into y. So this and this truncate. So what is remaining there is the y dx is equal to 3 into sine x all over x plus the natural log of this cos x into my y is what? Let's go back to the question now. My y is x raised to power 3 sine x. So that is the final answer. Remember that the final answer is 3 into sine x plus this cos x. X 3, x raised to power 3 sine x. Remember what I said in our previous video, that if a question like this is given, that you repeat the question again at the answer after you have finished differentiating the natural law what we introduced. So do well to drop question in the comment section below, and also subscribe to my YouTube channel. Thank you.